Hello students, today we will do Thermodynamics question part 4. So basically our today's focus will be practicing questions. So there will be questions from 25 to 32. So that will comprise total of say 6 to 8 questions, right? There will total of 8 questions. So we will be solving them. So I will read out the question for you. You will have some time that will be 10 seconds, and after that I will tell you the answer. Okay. So I would suggest that while I read out the question, you can just follow up quickly before me, and you can save extra time for your question. Okay. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owner of these images. If you are the owner of the images, if you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. Starting from question number 25. Question number 25 says that the entropy change involved in the isothermal expansion of 2 moles of an ideal gas from a volume of 10 decimeter cube to 100 decimeter cube at 27 degrees Celsius is. Your options are A 38.3 joule per Kelvin, B 35.8 joule per Kelvin, C 32.3 joule per Kelvin, and D 42.3 joule per Kelvin. So I would say your keyword would be for this question that you should know that this process is going on isothermally and there is a volume change only. Clear? So you have 10 seconds to solve this question. So let us see if you can solve it or not. Okay, now let us see the solution. So what was the question? So the question was saying that we are expanding a gas and we are doing it what? In isothermal reversible way. Okay, so these two words are important. And we are moving from a volume of 10 decimeter cube to 100 decimeter cube at 27 degrees Celsius or 300 Kelvin. So for those who have solved, the correct answer is A. So what will be the formula? So this is a simple formula which is delta S is equals to 2.303 NR log V2 by V1, or delta S is equals to 2.303 NR ln V2 by V1. Right? So we will just put all of this. So we have this volume which is 110, and we know what is gas constant, and the number of moles is also mentioned. So putting all of this, we will get this thing, right? So this log 10 will give you 1. Now if you multiply these three, it will give you 38.296 joule per Kelvin. So unit is very important. Why we are getting joule per Kelvin? Because R has a unit of joule per Kelvin per mole, and N has a unit of mole. So this mole and mole will get cancelled out. Mole and per mole will get cancelled out, and that will result in joule per Kelvin. Whereas this is a ratio of volume, so it will have no unit. Okay, so in this way you will solve this question. Now moving on to the next one. Question number 27. Question number 27 says that a Carnot engine operates between temperature T and 400, where T is greater than 400. If efficiency of your engine is 25%, the temperature T is. Your options are A 666.0 Kelvin, B 498.5 Kelvin, C 533.3 Kelvin, and D 500.0 Kelvin. So you have 10 seconds to solve this question. Before that, I would say that this is a very simple question. You are given T1 already. You have to see that what is T2, and the temperature which is given is the lower temperature. Okay, this is the temperature of the sink, and the efficiency is mentioned. You have to find the temperature of the source. Very easy to solve. So let us see how many of you can solve it. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see the solution. So this was our question. So the question was very simple, that your Carnot engine is operating between temperature T and 400 Kelvin. Now the efficiency of the engine is given 25%. So you have to find the temperature T. For those who solve, the correct answer is C. So this is the formula for efficiency, which is T2 minus T1 by T2, where T2 is the higher temperature. Okay, because efficiency can never be negative, so you can just remember this, that your formula is so sometimes you may get confused, right? So for that you can remember the formula in this way, that your efficiency can never be negative. So this one will be always a higher temperature, and that temperature is only present in the denominator. So T2 minus T1 by T2. Now putting all of this, so since it was given that T is greater than 400, so we will take T2 as T. Okay, so T minus 400 by T, and efficiency is 25%. So this is percentage efficiency and this is fractional efficiency. We are not multiplying this by 100, so we will get this efficiency as the 25 by 100 value. Okay, so that will give it 0.25 efficiency. Now solving it further, we will just cross multiply this thing, and at last we will get the temperature value as 533.3 Kelvin. So this thing will be in Kelvin. Okay. Sorry. Okay. Now moving on to the next question. Question number 27. Question number 27 says that in view of the signs of delta G R naught for the following reaction, PbO2 plus Pb gives us 2 PbO, where delta Rg naught is less than 0. And SnO2 plus Sn gives you 2 SnO, your delta Rg naught is greater than 0. So what is the question saying here? So the question is saying that you are being asked that in the view of the sign of delta Rg naught. So what does delta Rg naught says that? Says us, it tells us about the spontaneity of the reaction, right? So this is very obvious. So we have to find the say the oxidation state for the lead and tin, if your delta Rg naught is already mentioned. Okay, so keeping that in mind, your options are for lead plus 4 14 plus 2, for lead plus 2 plus 14 plus 2, option B, option C for lead plus 4 14 plus 4, and option D for lead plus 2 14 plus 4. So you have 10 seconds to solve this question. Your time starts now. Okay, so let us see who can solve it. Okay, so this was your question. So first of all, it is very obvious from this question that this process is spontaneous and this one is not spontaneous. So the reaction will proceed in the further direction, where in this case the reaction will not proceed because the delta G R naught is positive. As a result, what will happen? For those who have solved, the correct answer is D. Now, since this reaction is feasible, so your PbO2 will go to Pb. Okay, so it is plus 4 and it is plus 2. So since it is negative, therefore the reaction is spontaneous, and in the forward direction, this suggests that Pb plus 2 is more stable. Okay, as I have told you earlier. But what happens in the second reaction? So what is being done in this question is that, so we are considering that if the delta G is negative, then on the reaction will proceed and you will get this oxidation state. This means that this one is more stable. Similar is the case for here. But in this case, your delta Rg naught is positive, means your reaction will not proceed further and it will remain in the initial state or the primitive state. Okay. So keeping that in mind, we can analyze the second equation and say that your this reaction is not feasible and it will remain in SnO2, that is plus 4 oxidation state. So this will be plus 4 will be more stable than the plus 2. Hence, we can say easily that since delta Rg naught is positive, then the reaction is non-spontaneous and will be spontaneous in the backward direction. This suggests that your SN4 will be more stable than the SN2 plus. Clear? Now, what is the reason behind it? So the reason behind it is the inert pair effect. Okay, the reason is also given. This is due to the inert pair effect that your this two electrons are taking part in the reaction, whereas in case of PB, that is not the case. Okay. Now moving on the further question. Question number 28. Question 28 says that when the heat of reaction at constant pressure is minus 25 into 10 to the power 3 calorie and the entropy change for the reaction is 7.4 calorie per degree, it is predicted that the reaction at 25 degrees Celsius is options are A reversible, B spontaneous, C non spontaneous and D irreversible. The question is saying that when the heat of reaction at constant pressure means your QP is given as this value minus 25 2.5 into 10 to the power 3 calorie and the entropy change is also given. So you have to see that here whether your reaction is spontaneous, non-spontaneous, reversible or irreversible. So how you will see it? You will simply calculate delta G. Okay, because we know the spontaneity relation with delta G. So once you find delta G, you can easily get your answer. So you have 10 seconds to solve this question. Your time starts now. Okay. Now let us see the answer. So again the question is very simple. Your entropy change for per degree is given and your heat of reaction, that is your Q is given, and you have to find your reaction condition, that it will be spontaneous, non-spontaneous, reversible or irreversible at 25 degrees Celsius. Now the correct answer is B for those who have solved it. Now heat at constant pressure is nothing but your enthalpy. Yes. So this is your delta H. Now we have converted this into calorie. Okay, so it is already into calorie. We don't have to convert it. And your delta S is given as 7.4 calorie per degree. This is already given. And temperature is also mentioned. So delta G is equals to what? Delta H minus T delta S. So that is this value of delta H and this value of delta S is being substituted in this side, this equation, and we get this as minus 4705 calorie as your value of delta G. So very easy to predict now that since your delta G is negative, therefore your process will be what? Your process will be spontaneous. But in case you will find that your delta G is positive, in that case you will say what? Then you will say that your process was non-spontaneous. Okay, so this is the way we'll solve it. So what are the key points for this question? The first key point that you should remember this formula. And second thing you must remember that what is the effect of delta G on the spontaneity of a reaction. Clear? Okay. Now moving on to the next question. Question number 29. Question number 29 says that at 1 atm pressure, delta S is 75 joule per Kelvin and delta H is 30 kilojoule per Kelvin. The temperature of the reaction at equilibrium is A, option A, 400 Kelvin, B, 330 Kelvin, C, 200 Kelvin, and D, 110 Kelvin. So you have to find what? You have to find the temperature of the reaction at equilibrium. Your delta S is already given, delta H is already given. How will find it? So you should remember that your delta G is what? It is 0 at equilibrium. And once you know this, you can easily solve this question. So you have 10 seconds to solve this question, keeping that in your mind that your equilibrium condition will imply that your delta G will be 0. Now, let us start the clock. Okay, so moving on to the solution. So this was a question again. You are given delta S and delta H. Look at the units. Okay, the unit can make a chaos here. So unit is kilojoules. So I'll convert this into joule. So we have to look at the temperature reaction at its equilibrium. For those who have solved, the correct answer is A. So we know delta G is equal to delta H minus T delta S, and at equilibrium your delta G is equals to 0. Okay, so this is very very important. You should remember this, that at equilibrium your delta G will become 0. Hence temperature will be delta H by delta S, that is 3 into 10 to the power 3 by 75, and your correct answer will be 400 Kelvin. Clear? So in this way you will solve this question. So again, if I would say what are the key points, the first important key point is that your delta G should be 0, and the second one is delta G is equal to delta H minus T delta S formula should be known to you. Question number 30. For a particular reversible reaction at temperature T, delta H and delta S were found to be positive. If T is the temperature at equilibrium, the reaction would be spontaneous when options are A, T greater than T, B, T greater than T, C, T is 5 times T, and D, T is equal to T. So what is being asked in the question, that are given a reversible reaction, okay, and your delta H and delta S were both positive. Now if T is the temperature equilibrium, the reaction would be spontaneous. So when will the reaction be spontaneous? You have to find it. So you have 10 seconds to solve the question. Your time starts now. Now moving on to the solution. So I would repeat this question. So question is being in a way that your delta H and delta S both are positive. Now you have to see that if T is the temperature at equilibrium, the reaction will be spontaneous or not. So this thing you have to predict. Right, so delta H and delta S is positive, then you can easily get about the say Gibbs free energy value. Okay, so that would help you. So for those who have solved, the correct answer is B. So again, we use this formula, delta G is equal to delta H minus T delta S, and at equilibrium delta G is 0. Therefore, T is equals to delta H by delta S. Now, for the process to be spontaneous, delta G should be negative. So this implies that delta H by delta T delta S. So delta H is less than T delta S. So since this is less than this, then we can just cross multiply it and say this. So T is greater than T. Clear? So again, I am repeating the question. So this will be a thing. So what is the question again? So the question is saying that your T is the equilibrium temperature. So the reaction would be spontaneous when? So when will the reaction be spontaneous? When this value should be less than 0. Okay, so this we have put in the linear inequalities and found that if this is the case, then your temperature should be greater than delta H by delta S. So this is very obvious. And the second thing we know that then since T is the equilibrium temperature and delta G is becomes 0 at equilibrium, so we can find the value of T from here. So that gives us that your T value is equals to this. So if your T value is greater than this thing, that means your T value is greater than T also. Very simple to solve. Now moving on to the next question. Question number 31. Question number 31. For the process H2O liquid 1 bar 273 Kelvin is going to H2O gas 1 bar 373 Kelvin. The correct set of thermodynamics parameter is. So in this process, what is happening? We are doing a transition from liquid to gas, and you have to see that what is the effect of on delta G and delta S. Okay, so I would hint you that this process is going, this transition is undergoing equilibrium, is undergoing at equilibrium, and liquid is going to gas. So these are the two hints. If you are good enough, then you can solve it easily. So options are A, delta G is equals to 0, delta S is equal to positive. Option B, delta G is 0, delta S is negative. Option C, delta G is positive, delta S is 0. And option D, delta G is negative, delta S is positive. Now you have 10 seconds to solve this question. Your time starts now. Now let us see the solution. So this was your thing. So since this process is at equilibrium, then you can easily predict your change in Gibbs free energy. So for those who have solved, the correct answer is A. Because H2O and H2O liquid and gas both exist at same temperature and pressure. That means an equilibrium is being established. Hence your delta G will be 0 and conversion of liquid into gas increases the disorderness and your delta S is positive. So two things. First, since it is that this process is at equilibrium, so delta G is 0 and we are moving from liquid to gas, that is we are moving from ordered moving to more disordered molecule, because gaseous molecule are very random because of the higher kinetic energy they move here and there freely. That increases the randomness as we grow from liquid to gas. Therefore, delta S is also positive. So delta G is 0, delta S is positive. Now moving on to the next question. Question number 32. Considering entropy as a thermodynamic parameter, the criteria for spontaneity of any processes options are A. Del S system plus del S surrounding be positive. Del S system be 0. Del S system minus del S surrounding be positive. Del S surrounding be 0. So you have seen this type of questions earlier also, right? For that you should remember that what is the relation between delta S total system and surrounding and delta S total, because your delta S total should be greater than 0 for the reaction to be spontaneous. So if you know the relation between these three, then you can solve this question easily. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see the solution. Again, this was your question that the entropy is a thermodynamic parameter. The criteria of spontaneity is. Your correct answer is A. How? So for spontaneous process, this thing should be greater than 0. I have told you. And the sum of these two is equal to this. Therefore, a delta S should be also greater than 0. Now, this was for today's question session. Thank you.